In this video, we'll be looking at integers and rational numbers. We'll be covering a lot of vocabulary dealing with types of numbers. So the first one we have is whole numbers. Whole numbers are the numbers 0, 1, 2, 3, and the dot 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 meaning all of the numbers that come after that. So all the way up to thousands and millions and beyond. Integers are -3, -2, -1, 0, 1, 2, 3, everything after that and everything before. As long as they're whole numbers, so they're not fractions, they can be positive and negative. Note that both of them include the number 0. Positive integers are integers that are greater than 0. Those are positive integers. And negative integers are ones that are less than 0. Sometimes you'll be asked to graph a number on a number line. To do that, you're going to draw a line. Start out with 0, and then you can start labeling them up. 1, 2, 3, 4, and down to the negatives, -1, -2, -3, -4, and so on. So if you need your number line to be bigger, you can just go ahead and stretch it out. So if I were comparing -4 and -3 by graphing them on a number line, I would put a dot at -4 and a dot at -3, and then they would say which one is bigger. The numbers are always increasing from left to right. So since -3 is more towards the right than -4, the bigger number is -3. So you can say -3 is greater than -4. Now what if we had the number -4 and 2? Well, here we do the same thing, so you draw your number line. Make sure to label it. And go ahead and graph your numbers. So we have -4 over here, +2 over here, and once again, since we are increasing from left to right, we know that 2 is more towards the right than -4, so 2 is greater than -4. A rational number is one that can be expressed as a quotient or ratio of two integers. Examples include 2/5, 0.56, -7, and 0. All of these can be expressed as a fraction if we wanted to. So we could say 2/5 already is a fraction, so that's good. 0.56 could be 56 over 100ths. And you would want to simplify that. -7 could be -7 over 1. And 0 could also be 0 over 1. So again, rational numbers are anything that can be expressed as a fraction, whether it's a whole number, 0, a decimal, or already a fraction. Irrational numbers are everything else. So those are things that you cannot show as a fraction. Those would include things like square root of 2, which is known as a repeating decimal, which is a decimal that never stops, so it's 1.414213562 dot 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 and goes on forever. So there's no way to show square root of 2 as a fraction like the irrational numbers above. And pi, which is 3.14159, and it just keeps going on forever, is also a number that there's no way to show as a fraction. So if you can show it as a fraction in some way, then it's going to be a rational number. Another way to look at it would be to say that rational numbers are finite, so they have an end and you can see the end of the number, whereas numbers that are irrational are not finite, as in they go on forever. Absolute value is the difference between the number and 0 on a number line. For example, if you were to find the absolute value of -4, you would draw a number line. I'm going to say 0 is here, 1, 2, 3, 4. And you would draw -4 and 0, and the difference between the two is 1, 2, 3, 4. So the absolute value, and we write it like this, of -4 equals 4. So you're going to find that that's true for a bunch of different numbers. So if you do the absolute value of 2, and you put 2 over here, 2 is 2 spaces away from 0. So the absolute value of 2 is equal to 2. So the absolute value is the distance between 0 and the number you're looking for the absolute value of. So it's the distance between your number, so that'd be the one in the absolute value signs, and 0. So here in this next part we're saying A could be any number. So if that number is positive, then the absolute value of that number is just equal to itself. So we saw that here. So if you're looking for the absolute value of 2, that's going to be equal to itself, which is 2. If you wanted to find the absolute value of 4, another positive number, then that would just be 4. Easy enough. So if that number is 0, then your absolute value of A, which would be the absolute value of 0, will always be 0. And that's always true. If that number is negative, then the absolute value A will be -A. So that sounds a little bit tricky. So they're saying that if we say A is -1, so -1 equals A. So we say the absolute value of -1 is equal to the negative, so because that little negative right there, of -1. So if you remember from previous math classes, a negative of a negative number is a positive number. So 2 negatives make a positive. So this is just saying that if you have the absolute value of a negative number, let's try -3, it's just going to be positive. That's because distances can't be negative. So in our example up here at the top, when we're showing the distance between -4 and 0, it's positive 4. You can't have negative distance, so it has to be positive. So one more example, if we have -16, and we're trying to find the absolute value, that's the distance that -16 is from 0, which is 16 spots, because distance can't be negative. The last word you need to know is opposites. Opposites are just the same number with the opposite sign. So if I say, what is the opposite of -2? The opposite is +2. If I say, what's the opposite of +4? The opposite is -4. So go ahead and find the opposites for -1 and -17 and +3. Okay, now that you've paused your video and done that yourself, opposite of -1 is 1, opposite of -17 is just +17, and opposite of 3 is -3.